I'm Colleen from the Demonstration Theaters team at Carnegie Science Center. Welcome to the Something to Watch series, where we offer fun and educational science videos for kids, parents, and teachers. I'm currently at Carnegie Science Center in our Works Theater practicing social distancing, and for the next few minutes, we're going to explore together a little bit of chemistry. Let's get started. The last main branch of chemistry we're going to talk about is physical chemistry, which is the study of the structure and the behavior of matter on an atomic or molecular level. This can include topics like electrochemistry, thermochemistry, and nuclear chemistry. And when we think of women in STEM, one of the first women we think of is Marie Curie. But what a lot of people don't know is that her daughter, Irène Joliot-Curie, also followed in her footsteps with nuclear research. Between the two of them, they achieved 3 Nobel Prizes in physics and chemistry. Marie for her work in radioactivity and discovery of radioactive elements, and Irène for her discovery of artificial radioactivity. They went on to inspire technologies such as radiation treatments, as well as other scientists like Chien-Shiung Wu. When she came to America, she worked on projects like the Manhattan Project and the Wu experiment, though she was blocked from receiving recognition when her research led to a Nobel Prize. We're not going to be using any radioactive materials today, but we are going to be breaking it down and looking at the structure of atoms. One of the ways we can observe the structure of matter is by adding electricity to it. So we're going to do that using this emission lamp. I have some different tubes with ionized gases in them, and when we add electricity, they're going to glow. So for example, I've got hydrogen here, and when I turn it on, we can see that it glows a purple color. Now the reason it does this is because when the electricity flows through those atoms, they absorb the energy and the electrons become excited or go to a higher energy level. That makes the atoms unstable, so they're going to drop back down and emit that energy, and depending on the amount, that can come out in the form of visible light. Now we can take an even closer look at this using a tool called diffraction grating. Now the role of diffraction grating is to spread out the visible light into its component wavelengths. So for example, if we use our white flashlight, we can see that it's going to spread out into the whole rainbow continuous spectrum. If we look at the emitted light from hydrogen, however, we can see more distinct lines. This gives us information about the energy levels within the atom because only those specific amounts of energy are being emitted. Now this doesn't just work for hydrogen, we can use it on other elements as well. For example, we have another tube of neon. Now this is how neon lights work when we see them in signs at restaurants and things. It's just a tube with neon gas and electricity being run through. So we can see this nice bright orange color. But when we put the diffraction grating over, we can see that there's actually distinct lines within that red, orange, and yellow range that make up that combined color. This works not only for elements, but for compounds as well. So we're going to switch this out with a tube that has water vapor in it, and we'll see how that changes when we have a compound. All right, so we can see kind of a pale purple, almost white color. And when we put the diffraction grating over, we can see that it does spread into almost a continuous spectrum. There are distinct lines, but because it has that lighter color, it's made up of more colors of the rainbow. And so that's how we can use that electricity to find out more about the structure of the atom.
Another much larger example of emission can be found here at Carnegie Science Center with our large Tesla coil. This Tesla coil right here is over 100 years old and is going to be a great example of the things that we saw earlier over there. Are you all ready? Here we go. In 3, 2, 1. With the Tesla coil, the colors that we'll see up there are purple and a little bit of blue. That's because the air around us is mostly nitrogen with a little bit of oxygen. Nitrogen, when it's excited, glows purple. Oxygen glows blue.
Now the next time you come to the Science Center, look for our friends in red doing fun experiments like these ones in our live demonstration theaters. For more fun science videos like this one, log on to carnegiesciencecenter.org for more things to watch, things things to read, and things to do at home. Thank you for watching and hope to see you soon at Carnegie Science Center.